All right, so last study group of the week, we're going to be going back to object-oriented programming. This was at the start of the phase, technically, because it is topic 21, but I felt like it was good to just dive straight into the models, and this is kind of separate. Some of the concepts do help explain how Python works and how libraries work, but I would say for data scientists, we don't use object-oriented programming directly that much, but good to know. Reason being, some of you, depending on which direction your job search is going, might end up interviewing for more um, broad positions. Like for example, some companies like to hire classes of new hires and like them to do more general things, and object-oriented programming might end up being a part of that interview process. I myself have had a couple object-oriented programming interviews where I'm asked to like define classes. Still not the most familiar thing to me, but good to know some of the basics just so you're not like, what is going on? All right, so let's get started. In this course, we've actually been creating objects. And these objects come from the built-in classes provided by Python or anything that we're importing. I have an example with pandas that I'll walk through in a little bit. So objects actually include things like integers, strings, and lists. In addition, we've been organizing a lot of our things into functions, hopefully, that can help process and manipulate your data. So this whole idea of creating functions to make programming more streamlined is known as procedural programming. Also, maybe known as functional programming. So the idea of putting all of your code into functions is known as procedural programming. Now we're going to learn a little bit about object-oriented programming that allows you to create your own objects and procedures from classes that you design. Object-oriented programming overall is useful because it speeds up development, especially if you want to do a lot of repetitive objects, and we'll go through a bunch of different examples through this notebook. And it also makes your code more reusable. So before we get into actually creating objects, some very important terminology. Some of these words might seem familiar, but here we're going to really root it in OOP context. So with object-oriented programming, you're going to be creating a class. And you can sort of think of a class as a blueprint for how to create your objects. So within your class, you will actually define what your objects are going to look like. So in this case, the class in this example is humans. And the objects created from this human class are going to be individual people. So in this analogy, class is just like, the blueprint of like what a human is, and the actual objects are people. Now, people have properties and methods. Properties being things like, properties is also another word for properties that you might see more used is attributes. So properties or attributes, basically things about each person. In this case, you have like the person's email, the person's address, and you also have methods. What can the person do? With this example, the person just verifies things and also can send mail. So this is some of the terminology that we're going to be using throughout this notebook. Questions to clarify this setup so far? All right, so Python is actually an object-oriented programming language. I'll show you an example where every data frame that we're creating is actually an object. And you'll hear people say that everything is an object in Python. So what does that mean? Taking a step back to think of functions and how functions work. Function is a kind of abstraction where an algorithm is made repeatable. So instead of coding a number squared plus 10, like let's ignore this for now, but let's say you're doing this, you want to do this over and over again, instead of just doing it individually or doing something like a for loop, you can write a function that does this, and then you can just feed it in a number and you save a lot of coding space. So imagine a further abstraction where before creating a function was about making a certain algorithm available to different inputs, right? Again, here, whatever you put as X it'll perform this function if it makes sense. So whatever number, or I guess any float or integer that you put in, you are able to perform this function. Now, what if you want to make this function available to different objects? So currently, this function works only on integers or floats. So an object is what we get out of this further abstraction. So every object is an instance of a class that defines a bundle of attributes and methods. So the class is what defines what attributes and methods each object will have. So yes, every object of that class will automatically have those proprietary attributes and methods. So yeah, everything in Python is an object. And again, I'll show you that pandas example right after this. Even attributes and methods of objects sometimes can be their own objects. So you can really go in layers. So let's start with this data frame example. So when you create a data frame is actually an object as well. So when we're setting df to be this data frame, this df now has all the attributes and methods that a data frame has, right? Because now that we've set df to be this pd.dataframe object, we can call .shape, which is an attribute. We can also do .info, which is a method. So we are actually playing around with a lot of objects in Python. We just didn't know it yet. One quick thing to clarify here, anything that's an attribute has no parentheses at the end. So what's another one besides shape? I think dot columns, and this one has none. Anything without the parentheses at the end is an attribute, and anything with the parentheses, like even .head, is a method. And right now this is an empty data frame, so there's nothing there. So when you've been doing this with data frames or even with like NumPy arrays, you've been playing around with objects all this while. So yeah, to summarize, in this case, let me move this down. I'm setting this x to be equal to an integer. So what we're actually doing here is we're imbuing x with the attributes of the integer class and the methods of the integer class. And then often methods will provide a way to modify the attributes of an object. In the examples that we will go through, we can take a look. I don't know too many of the attributes and methods of integers, but one really neat thing, and one really neat method I got from just Googling what kind of methods and attributes an integer has, you can actually find the bit length of an integer. So here you see this, x being this number will have a bit length of 22. Versus, let's say I just have x equal to the number 2, and let me move this up so it won't scroll down all the way. This has a bit length of 2. So this bit length method that is built into the integer class will calculate the bit length of this integer. Any questions so far? Awesome. All right, so in object-oriented programming languages like Python, an object is an entity that contains data along with associated metadata and or functionality. So this is just repetitive. Every entity has some metadata, attributes, and also functionality methods. And these attributes and methods are accessed via the dot syntax. And again, as I mentioned, attributes don't have the parentheses at the end, methods do. So yeah, as another analogy, you can sort of think of the class being a blueprint, and any object that is a result of the class is the object. All right, or an instance of the object, an instance of the class. Yes. All right, so let's do like a step-by-step creation of classes. We're going to start with a very simple class, and we're going to keep adding to it throughout this notebook. So with classes, you define a class in kind of a very similar syntax as defining a function. We're going to start with this empty class and we'll build on it. So this one is just going to be, we're going to create some robots. And also a syntax note about creating classes. When you create classes, it's usually an upper camel case. An upper camel case basically means you start with a capital letter, and every time you have a new like word, you use a capital letter to denote that. So if my class would be robot machines, it would look like this. That's upper camel case. Regular camel case would start with a lowercase letter, just in case you come across this terminology. It's called camel case because like the capital letters will create like humps like a camel. All right, so let's create this robot class. Right now, I don't want it to do anything. I don't want to define any attributes or methods yet. So let's just create a blank robot class. So how you create an object, this is actually going to look very, very similar. And it's actually exactly the same thing as what you're doing when you're instantiating your model. Here, previously with all your modeling, you're instantiating blank models, then you feed in your data and you can call like .fit, .predict, those are methods. And from your model, you can get like your coefficients, that's an attribute. You can get feature importances, those are attributes. So in exactly the same way, let's instantiate a robot. So all I have to do here is I want to assign it to this variable, my robot, and then I just call the robot class. So right here, with my robot, something to note is that you can't really see what the object is. So my robot, it just tells you that it is a robot object. And this tells you where in your computer's memory they are storing this robot. And right now, our robot has no attributes. So let's take a look at, and we're going to do this a little bit later. But let's do this. For each robot, and I'm going to do my robot and your robot, I'm going to do this twice. We're going to instantiate a robot and give it some new attributes. So one pretty neat thing about classes, if nothing is defined to stop you from doing this, you can create new attributes. So here, what I'm going to do is I'm just really going to create a new attribute, an attribute known as name, and another one for height to just store this information. And we'll see what that looks like. So I'm going to do my robot, give it the name of Wally and a height of 100. I'm also going to do the same for your robot, give it the name Bob and a height of 200. So let's run this real quick. Now that we've run this, my robot is this robot object. But now when I do my robot.name, because name is an attribute, you can see that it returns Wally. And if I do height, it returns 100. Same for the other one that we instantiated. Your robot.height is 200. So we're actually just giving it these attributes this way. Later, we'll see how we can give it some default attributes within the class. But if you just want to add attributes to your own object, this is how you can do it. A pretty neat way of storing data. And later, I'll talk about a potential useful application for data scientists where we use this. Right, so we can just print this data out. You can see that this is the name and height of my robot and your robot. So this is a little bit out of order, but let's say we want to give these robots purpose. If you look for the purpose before you assign it, it'll say that it doesn't have this attribute yet. But then if I assign it this purpose and I rerun this cell, we see that that purpose is there. Just again goes to show that we can continually add attributes to our own classes. If you try and do this for like scikit-learn, they probably have something in place to stop you from creating new attributes. Questions so far? All right, so here we've talked about just giving random attributes to my empty robot. Here's where we can add default attributes. So let's just say for all robots that we make from this class, we want to give it this purpose, and let's just say we want to give it this weight for now. So if I rerun this robot class, so I'm redefining the robot class, and reinstantiate a couple of these robots, let's take a look and see what happens. So again, I'm going to do the same thing, instantiate my robot and your robot. And because I reran this class, it's going to use this new class. So same information, and you'll see that my robot's purpose now is to always protect humans. Just because this is anything created from this class now will have these as default attributes. Questions so far?
So it doesn't use the attribute that outside of the class it was?
Yeah. So it actually does have all of these attributes as well. So remember, we have given it these attributes that weren't part of the default ones. So if I look at my robot dot name, it's still Wally, but it also has its default attributes, like weight is going to be 100 and purpose, as you can see, is this. So you can give it attributes both ways. If you know that all of your objects from this class are going to have the same value for a certain attribute, you can put it in the default, but you can still add your own attributes afterwards.
Got it.
Anything else? Cool. Another thing about these attributes is you can actually overwrite these, which is pretty neat. You can overwrite attributes. So let's just say that we have this evil robot here. Again, name is not a default attribute, so we're going to give it the name lore. And then we're going to overwrite its purpose to kill all humans. So with that, when we run this cell, what is your name and your purpose? You can see that this evil robot has these new attributes that we gave it, and it does overwrite the class default ones. So let's say you want to create a bunch of objects, mostly the same with a couple exceptions. You might put them all as defaults, and for the couple exceptions, maybe do something else to overwrite them with whatever exceptions you have. So attributes can be overwritten if there's nothing else in your class to stop you from doing that. This is again just to show that you can run a bunch of different functions comparing your attributes to each other, because it's really just data stored. So here is just comparing the height of the robots. So I'm not going to go through this too much, but you can see that apparently Rob is the tallest bot at 200 cm. You can compare your objects. All right, and again, I think I went through this earlier. Where are the robots in memory? This hash code tells you where in your computer's memory this information is being stored. Again, I'm not familiar with hardware, so I don't know exactly where this is being stored, but it gives you some address to find your objects. All right, so let's just do a quick check of, are the objects the same? So is my robot equal to your robot? Even though they came from the same class, they are different. So here you can see that they're not the same. And also, are you yourself? It is myself. My robot is equal to my robot. Again, as a quick recap, does anyone remember the difference between using a double equal sign versus is? Might be an interview question. I've never gotten this interview, but I feel like it's good to know.
Doesn't is mean they're actually stored in the same place in memory?
Absolutely. Yeah, that's right. Thanks, Melody. So the is will tell you whether it's literally the same thing stored in the same place. The double equal sign is seeing if they're equivalent. So, you know, if you do like 2 plus 3 is double equal to, what did I say earlier? 2 plus 3 equals to 4 plus 1. That's equivalent, but they're not exactly the same. So yes, that's the difference between is and the double equal sign. All right, so let's build on our class even more. So we've talked about our classes, we talked about our robot class, and now we're going to have more default attributes. Name we're going to set as none to start. Give it material made out of metal. It is electric and has 2 arms. So with this instantiation of robot 1, we'll just take a look. Oops, I didn't run this. There we go. After I instantiate robot 1, you can see that robot 1 has these default attributes right off the bat. This again goes to show that we can overwrite this none under the name to actually give it a name afterwards, and you can add new attributes to your class. So now our robot has a name now and has additional attributes. So yeah, something pretty flexible with objects that you're defining on your own. You can have a different number of attributes per object. It just depends on, you know, what information you're updating. All right, so I think this, yeah, let me just double check. Yes, this closes out our section on just attributes of objects. Any questions so far? All right, so there are attributes and there are also methods. So we're going to talk about methods now. So with methods, you actually define them like functions. There are different ones, and let me actually just start with this. Yeah. So when you're defining a method, there are actually two different kinds of methods. First, I'm going to talk about class methods, and then what's the word? Object methods. Is that what it's called? Yes, object methods. So there are class methods and object methods. Difference being, there are methods that work on the class itself, and there are methods that work on the object. A good example would be, imagine with pandas, you have some methods that work on the data frame, and then there's some methods that you have to call out of pandas. For example, something like df.hid is an object method, and something like pd.readcsv works on pandas. So that's the difference between them. Class methods work on the class, and again, robot is going to be our class. And then there are methods that work on the objects themselves. And we're going to walk through some examples of both. So we're going to start with class methods first. So with class methods, you literally just define them within the class. Whatever arguments it's going to take, you can give them as well. So within this class, I can actually define the laws of robotics here. And these laws of robotics, because I'm defining it in this way, similar to how I was defining these, even though it's a list, an attribute can actually be a list. So now all of the robots are going to have this laws of robotics attribute that I can pull out. So let me just run this first. And you can see that if I do my robot.laws of robotics, I'll return this list of laws. So attributes can also be lists. It can be pretty much any sort of data. It can also be another object. That's something that you can also define an object within an object. That is a thing too. But we're not going to talk about that. There are a couple additional lessons in the appendix of phase 3 if you're interested in doing more of this. So a couple of the class methods that we've defined here. Here, we're just doing print laws, and literally it is going to print each law in laws of robotics. One thing to note here, the syntax, because laws of robotics is being defined within the class, you have to do robot.laws of robotics for it to recognize what this is. If you don't do this robot.laws of robotics, it doesn't know what laws of robotics is. And then we're just going to print each law. Same for this one, or similar for this one. You're going to print a specific law. If you get a number from 1 to 3, it'll print the law. And if not, you'll print that the law doesn't exist. So this has already been run. You can see we can do robot.print_laws. It'll print the laws again. And then we can do robot.println_law2, print the second law. If we want to print the 5th law and there is no 5th law, it'll say the law doesn't exist. I think this is meant to be an F string. There we go. The 5th law doesn't exist. Questions about defining these methods? All right. So let's just create this robot called Wally. Let's take a look and see what happens. So Wally, we're going to instantiate as this robot. And again, we're just using this one, the one that just has the laws of robotics as an attribute. From Wally, remember that laws of robotics is a class, it's an attribute. So we can pull out the laws of robotics from Wally. And then let's see if Wally can print the laws. So here you say Wally cannot print these laws because print laws happens to be a class method, not an object method. So again, print laws, because it is a class method, only works if we do it after like robot dot whatever. So therefore, Wally cannot print laws. Does anyone have any questions about this distinction of why this cannot happen? It's like you're trying to do like a pd.readcsv, but instead you're trying to do df.readcsv, which doesn't make sense. All right.
So you're saying that pandas is a class, but then a data frame is also a class?
Data frame is an object. Data frame is an object. I know I said data frame is a class earlier. Yeah,
I'm just trying to follow. It seems like it's very embedded, but pandas must define classes inside it?
Yeah, yes. Pandas
Okay.
defines classes inside it. Yeah. Any other questions? All right. Okay. So when you're doing an object method, there's this concept of self, and the way a way a function knows is if it's an object method or a class method is if it's an object method, the function has to take in self as an argument, and that's the way the function knows what to look out for. So here, we're redefining this class. Again, it has all these attributes first, and we're going to have an object method that just has the robot tell you its name. And also, we'll talk about this adding numbers one in a bit too. So let's redefine this class, instantiate this robot, and let's take a look and see what happens here. So over here, you can see that now Wally can speak and Wally can add numbers because we've given self as an argument in these methods. Very important that self is the first argument that you pass, that you give to the function. Another thing is also that when you're actually using the function, you don't need to give it self. It automatically knows that self is the first argument. So as you can see here with this add numbers, I'm only giving it the 2 numbers, even though they ask for 3 arguments. It just automatically knows that the object itself goes into self. This part took me a little bit of time to like understand, but any questions on this? All right, so these are object methods. If we go back to what we had earlier with this print laws, all we have to do to have an object print the laws is if we just give it the self as an argument. You can see if I rerun this class, and let me just make sure I rerun all of the right things here. If I rerun these two, instantiating with that robot class, it can now print the laws, because now it knows that print laws is an object method because I gave it this self argument. Any questions so far? Cool. Okay, so a couple more examples of what we can do here. Again, we can overwrite the name here and still have it say, need to rerun this. So in this class with the object methods, I can rerun, oh right, here I can change the attribute of the name to give it the name Wally. And when it speaks, first it says I am none. When I change the attribute, it automatically knows now speak, because speak calls on self.name. So yeah, it knows to overwrite its name. Also, you can technically change the method. Methods can kind of be overwritten. I would say this is a little more advanced. I personally don't fully understand how this works either, but this will change the method for this specific object. So for example, I'm resetting Wally.speak to be this function, and it's a Lambda function that says that version of Wally. And when I run this, it will speak that. However, if I instantiate a new robot, because these are the default methods, this will speak the originally defined method. So this goes to show that methods can also be overwritten, but the defaults will not be changed. All right, that's all I had to share for object-oriented programming. That was pretty much a very brief overview of what you can do. Any questions about this before I talk about some potential data science applications?
In some documentation, when we see the self, what we should do exactly in those cases?
Yeah, in documentation, when you have the self, usually if you're reading documentation and you see self, you don't have to give it the self, because those would be methods that are already defined to work on an object, if that makes sense. So that means self, it will automatically know. So for example, here, when I do like Wally.speak, speak takes in the self argument. So it automatically knows here that the self is going to be this. So you don't have to do like Wally.speak Wally. That's not something that you have to do. So self, for the most part, you can kind of ignore it, but just know that it does refer to the object that the method is operating on. I don't know if that was helpful.
Yeah, okay, thanks.
You're welcome. Any other questions? All right, so the one main application that I can see being useful for data scientists and like of object-oriented programming is there are these things called object relational mappers. And object relational mappers sort of think of a SQL database. I know we haven't talked about SQL in a while, but imagine a SQL database where you have a lot of relationships going on. For example, maybe you have a SQL database of songs, your Spotify songs, and you have like a list of all of your artists, a table of all of your artists, a table of all of your songs, maybe a table of all your different albums. So in ORM, if you have all of this information stored in an ORM, each row or each piece of information would be an object. And because, with this data, there's going to be a lot of relationships, right? Like artists create songs, songs are part of albums, artists also create albums. In an ORM, the way it's set up is from any one table. Let's say I have an artist object. From the artist object, if I do like artist.songs, I'll see all of the songs that are attributed to that artist, if that makes sense. So you'll literally be able to like query objects, which is pretty cool. And you use it with this library called SQL Alchemy. Again, I'll send out resources if anyone is interested. It is pretty hard to set up. I will tell you that when I was doing the course, our phase 1 project was to create an ORM, and it was awful. But just letting you know, that is a potential application of object-oriented programming. Like you basically store objects in your SQL tables, and that has all the relationships embedded, which is pretty neat. So yeah, that's one that I can see might be helpful for data scientists to know. Yeah, any other questions? Cool. With the rest of the time, I did want to talk about some project things. Let me pull up the guidelines doc so I can point to some things that I've added. So this is our project guidelines doc. I've added a couple things down here. So I know yesterday I talked about SMOTE. Some people found it still kind of confusing as to like, all right, what do I use my SMOTE data on? Do I train with my SMOTE, and do I like predict with my SMOTE? So this is just my quick giving you the answer. When you do your fit sample, you have your SMOTE data here. You fit your model into SMOTE data, but you still only predict on your unsmoted data. That doesn't make sense. We can talk about it in a one-on-one. Something else on the note of SMOTE, there is also another way to rebalance classes known as TOMIC links. And TOMIC links is an undersampling method. It's actually pretty neat. I've linked the documentation here. It's actually from the same library as SMOTE, and also a pretty good explanation of how it works. But as a quick overview, if you have like a big class imbalance, and let me just do an example here. Let's see. Let me get all of my stamps out. So let's say you have a class imbalance that looks something like this. This is your majority class. And then here is your minority class. All right. So this is a very exaggerated example. But how TOMIC links works is it looks for pairs of opposite classes that are close to each other. So for example, you can see here, these 6 stars and ticks are very close to each other. It knows that these are like the closest tick star pairs. And what it does is it helps with the separation of your data by per each pair, it just removes the star, if that makes sense. So I wonder if this eraser will help. So it will remove this star, this star, this star, this star, this, not that one, damn. Let me just put those two back here. So your data will look like that. So it does help with the separation of your data. Downside is you do lose a bunch of data points, but your data will be more separable. So this is another rebalancing method that you can try if SMOTE is not helping, because as I mentioned yesterday, SMOTE, you're really just creating new data points within the domain of your minority points. And if they already are overlapping a lot, it might not help too much. Questions about that?
It is useful for every model, because what I see it is more useful for like SVMs.
Yeah, pretty much. I would say, is it every model? Honestly, I think every model, because even with k-nearest neighbors, it cleans up your neighbors a little bit. SVM, yes, definitely SVM, because it makes it more separable. Decision trees and any tree-based model, again, you can see that it's easier to get lower entropy or like more purity in after each split. So I do think that it would help with every model. Downside just being you lose some data. What other models have we talked about? Bayesian probably as well, because just in space, your points will be more separated. Yeah. Any other questions? All right. Let's see. Let me just double check to see if there was anything. Oops. There's anything I wanted to talk about here. The next thing I wanted to talk about was importing functions into your notebooks. So we talked about creating functions, but you can technically, if you find yourself creating a lot of functions, it will end up taking a lot of space in your notebook. And it's arguable that like functions don't have like a clean place to be in your notebook. If it's a little harder to set up that way. So I wanted to talk about how you can do that. And I'm going to be using I'm pretty much going to be using my old project as an example. So in here, and let me pull up what I had with the functions as well. So what I did here, and what you would have to do if you want to be able to use your functions without having them actually in your notebook, if you want to import your functions, all you have to do is create a Python file. And this can be done within Jupyter Notebook. You can really do, and actually let me just put this here as well. Here, all you have to do is, it's in the way, give me a second. All right, so if I do new text file and I want to create a Python file, all I have to do is do functions, and I have functions one already. If I do functions 2.py, and it automatically turns into a Python file. Alternatively, if you're comfortable using like VS Code or Sublime, or I use Atom, any one of your text editors, you can do that there as well. And most of them also, I believe, automatically recognize the file type based on the extension of your file name. So what you want to do is create a Python file and put all your functions in this functions py. So you can actually have multiple functions in each .py file. One thing to remember is to import all of the libraries that you're going to need for your function to work. So once you've done this, and this is pretty easy to debug if you import your function and it says that something is not defined, you probably just didn't import everything. So after you have this here, and I already pre-ran this because I have some data processing thing that take a while. Oh wait, let me put that here. All right, so what you're gonna do, and what you can do to use your function that is in this separate py file in your notebook, is all you have to do is do from functions import evaluate. So from functions, it knows to look in your directory and look for this functions file. You don't have to do functions.py, and you can import the specific function. Here, importing evaluate, and once I have that, you'll see that I can actually run my function and I get my results. Again, depending on what your function is, you'll have different outputs, but that is how you would use functions from a Python file in your notebooks. If you have multiple functions, you would do import evaluate. Maybe you have one called like metrics. You can import multiple functions like that. Also, if you decide to put your functions in a different folder, the way you would deal with that, if let's say you have a scripts folder, you would do it like this. So let's say your functions file is in a scripts folder, which is on the same level as your notebook. You do scripts.functions import evaluate. So that's how you deal with the different paths. Questions about this? All right, common errors. Honestly, a lot of people just don't import everything. It is a good practice to not just literally copy and paste all of these into here if you don't need them. But yeah, because of that, it's good to like look and see exactly what you're using in here and then import them here as well. Any questions on this? This is something that I did recommend a lot of you try. So yeah, if you run into any issues, feel free to let me know. I feel like this is something that isn't explicitly anywhere in the curriculum, so I thought it was useful for this. Questions? Cool. Something I wanted to show you all yesterday, but I didn't get to, is I wanted to show you all an example of how I put this onto a web application that I will show you all how to do when we get to capstones. So this is literally this project where I can classify my text, literally put any text you want and it will classify. This project has it classified as programming text or artsy texts. So here you can see that that is a programming text. If I say I like painting, that is an artsy text. Yeah. And the other thing I wanted to show you all why creating functions is important is let me quickly reshare my screen. Where is that button? Wow, where did I drag the toolbar? Sorry guys, give me a second to find my Zoom toolbar. Okay, weird. So the meeting controls, there we go. And I wanted to share this. So it's good to get used to writing functions because in the future, when your projects get more and more complicated, you're going to be having to deal with a lot of functions. And that web app that I'm running literally runs off of this whole file of functions that I have here. So if I zoom in, this is very similar to the function that I showed you all yesterday. It's pre-processing my data and returning the result. That will give me those different results based on your classification. So very, very important if you want to create something like this to get used to writing functions. And if you need any help with it, please let me know. All right, any questions about this so far? Cool. All right, I wanted to reshare. Let me just reshare this. All right, now back to project 3. Something that I wanted to let you all know is technically the project is due next Sunday, but you have that extra week due to break. If at any time you want to send me your project notebook to have me just look over and make sure you're going on the right track, happy to look through it. So just feel free to, it doesn't have to be like a PDF like the submission is. Feel free to send me like a GitHub link or even like your notebook file. That's easy for me to look through. So feel free to do that if you ever want me to look through your intermediate work. Let's see, what else? Does anyone have any other questions, either regarding anything I've said so far or the project? Nice. The first office hour of next week is actually going to be on Monday because our holiday starts on Friday. So we do have a study group on Monday next week, and I will be talking about presentations because a lot of your presentations were long the last time around. I've reformulated like my presentation template to talk about more like specifically what is good to include in a presentation and what might not be as useful. So look out for that coming on Monday. That will only take maybe like 20 plus minutes. So the rest of the time I'll take questions as well. All right, any final questions?
I forgot to answer it when we were going over smote, but can you use that with text data, or would it not work with that?
Absolutely, you can absolutely use it with text data, as long as you have your data split up into columns, and they're all numerical within their columns. You can use smote.
That's crazy. Cool. Thank you.
Yeah, it's pretty cool. Yeah, anything else? Cool. Again, I will be putting all of you who are working on non-provided data sets into a channel, so look out for that. I keep forgetting that, but I've made a note for myself to do it. So yes. Any other questions? All right. Well, in that case, hope you all have a good weekend. I'm going to stop this recording. You all know what's coming.